Good morning. Good morning, everybody. Thanks so much for having me. It's incredible to be here in Buenos Aires at one of the centers of crypto adoption. It's incredible to see how it's uplifting the human condition all over the world and really seeing it in action here in BA. So it's incredible to be here for the first time as well on the DevConnect stage. So today I want to talk about something that's a little timely, perhaps. There's been a lot of hype, a lot of speculation about how AI, right, is going to change everything. And along those lines, crypto's kind of been battling for this narrative dominance, and so crypto too is going to change everything. And so it's natural to assume that together, crypto and AI is going to change everything. Or will it? And if it does change everything, is it for the better? So I really want to spend some time today going a little bit deeper into some of these claims about how crypto and AI are inevitably going to merge together and whether it has a home on Ethereum or not. Now, I think it's really important to consider deeply what happens when AI agents actually start acting on chain. So what I mean by this is what happens when AI agents aren't just, are actually transacting. They're not just a chat GPT output or a browser window output or an interface that you copy paste from, but they're actually submitting transactions, that they're signing and moving value. So if that happens, right, if we're giving AIs private keys, whose private keys are we giving? And how do we actually allow agents to augment human capability without allowing them to own us? So it doesn't seem yet that there's a clear answer. There's tons of folks working on this. At least at the protocol level, there is no answer within Ethereum on this question. But I want to introduce you guys to something called WAP, which I think does have the answer. So, how many here in the audience today or online would really trust an AI with your private key? Would you trust an AI with your private key? Nope. I'm seeing no's all over the place. I think that's a really wise decision. The cypherpunks in the 70s and the 80s told us time and time again, never give up your private key. Keep it on your device. Don't store it on a server. Don't give it to anyone else, because that's what really secures your communication. In crypto, it also secures your assets. But here's the thing. Today, every on-chain agent is going to require full custody of your private key to do anything actually useful. There are some hacky ways around this with the multi-sig, right? You can have an AI agent as a signer on a multi-sig, but this is just a really primitive way and doesn't really help anything. So if we're going to do this, we're going to have to be able to really find a way to scale this safely where we can allow AI agents to actually interact with us without us giving them our keys. Because once we give agents the key, they're going to own the wallet, and then if the accelerationists are right, then agency is at risk. So there's this kind of a really difficult trade-off, right? This kind of unstoppable force meeting an immovable object situation where agents need autonomy to be useful, right? They need to be able to go off and do things at the speed of lights, but humans need to be able to control it, right? And it takes a human about 350 milliseconds to make a fast decision, right? So how do we figure this out? AI agents need to be able to monitor, to act, and to automate, but we still need to have humans as a root source of authority. And Ethereum does treat every single signature as the same, right? You just see the bytecode, you see the EOA or whatever smart contract you're interacting with, and it has no way to really know who's human or who's not. So ETH can enforce who's human on chain or who's a bot. It doesn't know what rights that entity has. Oops. Computer fell asleep. There we go. I think we'll be back in a sec. It doesn't know what rights a particular person has, and it can't distinguish from an unauthorized or a delegated action. It has no idea, and that's by design, right? There's a very good reason why we do this. So this really is a blind spot, I think, for how we bring AI into crypto, and then there's some rich design space we can explore here. So before I go any deeper, though, let's take a moment to pause and reflect on what do we really mean by human-aligned AI? What does it mean to design an AI specifically that's human-aligned on Ethereum? So the way we're approaching this, the design philosophy we're setting up, is that we're giving agents autonomy, but within boundaries of control. And these boundaries are enforced by cryptography, not trust that, say, some custodian or trusted execution environment is going to be able to keep the AI and your private key secure. So this means functionally creating a system where, one, the human is the root authority, and the agent is considered kind of like a co-pilot, right? And the wallet wraps these two things together to enforce safety rules. So for us to do this, we're going to need new primitives for Ethereum. One of those primitives are going to be human-bound keys, or human keys. This is something we've been working on at human.tech, where we're able to create keys from human attributes using what's called a verifiable oblivious pseudo-random function. It allows us to take things like biometrics or combination threshold of different human attributes and create a key that uniquely belongs to an individual. So this controller key is the most important, right? If you have an EOA, you're still going to need a controller key, whether it's a seed phrase. If you're a smart contract account, you're still going to need a controller key. This controller key should be derived as safely as possible. It shouldn't ever reveal any personal data, and it should also be powerful enough to enable permission delegation so that, say, you can use this key to sign delegates to act on your behalf. This key should also be non-transferable, so we don't want to end up in a situation where if AI agents can then imitate or make really good approximations of humans by passing the Turing test and then buying these keys on the open market. So now non-transferability seems to be something we should be considering carefully. So if we have a human key, the only other missing piece is delegation. So if we really want to be able to use agents on-chain as they were intended to be, agents should be thought of as holding capabilities, not the keys. And we define capabilities by delegating certain, say for example, traits or permissions. These could be, for example, like spending a certain amount per day, or only signing specific payloads that meet some, say, like regular expression pattern or some predefined set of patterns that you care about. You could also have sandboxes or closed safe spaces where these agents can only publish to whitelisted accounts. And you can imagine many, many different variations of this, right, where you require human approval above certain conditions or if the risk level of a transaction increases. So what's interesting about this, for those that are kind of following this carefully, is what you're seeing here actually is, okay, we started off by adding agents to, say, like make crypto easier to use or to, really tap into the power of AI. But it might end up actually that we increase the user experience and security of users through this merger. I'll talk a little bit more about that in just a sec. So how do we do this? How do we actually have a situation where we can delegate and define capabilities for AI agents safely using a human-bound key? One architectural solution for this that's kind of, I think, uniquely suited specifically for this use case is two-party compute, multi-party computation. So this is a primitive within the distributed compute space within computer science that allows you to basically take a key, split it into two, and have a user interact with a network, or even a user interact with one network and a second network. So the first network could be one to create the key, and the second could be another one that's used to execute an agent's policies and present a transaction for signing. So how would this work? You take the key, you split into two, you have some MPC network that has predefined policies set by the user, or it could be the DApp even, depending on the use case, and then that logic is enforced by MPC. So if there's, for example, say, I don't want to sign a transaction that's riskier than, say, this AI agent estimates 0.8, risk, then I want to make sure that I'm getting a passkey notification, a notification to authorize my passkey. I'm getting a notification to use my my Google Authenticator, and I want to make sure I also get a magic link to confirm before I send out $1.3 billion out of Bybit, for example. So one really important design consideration here as well is revocability. So being able for the human to turn off the agent, right? So at any point being able to just shut things down and revoke a transaction at any point. And we can do that with 2PC MPC by splitting the trust in this way. So if you can bring all these pieces together, we can start thinking of wallets and AI as kind of a singular interface into crypto. where AI acts as an embedded copilot within the wallets. And if the wallet's designed in a certain way that's also embeddable, you can propagate that everywhere. So you can have these kind of super wallets, right, with agents built in that can help draft transactions, find the best routing, significantly enhanced UX within crypto. You can do things like, monitor positions, unwind a position from, say, wrapped, staked, Lido ETH in Aave, pay the loan off, etc. And you can execute these automations really safely. So the other really cool thing is if you're doing this, it would be really cool to do this on chain, but with MPC, it's pretty straightforward. And today you can do this to have like push notifications that alert you when certain things are just off. But in no case should we really be building systems where the agent owns a private key or that they can bypass constraints, either say explicitly or by proxy, right? By imitating a human or presenting the human with different information or buying some other human's key, for example. And so we really want to make sure that we're wary when we're setting agents up to become custodians. So, agents and Ethereum, how does this actually play out in the future? So right now, Ethereum is missing a few things for this to be instantiated today. There's no way really to tell at the protocol level whether a transaction or an action came or an intent came from a person or a bot. That's really important if we're going to scale AI safely. Ethereum has really no way to tell whether there's like, some particular scope or delegated action actually occurred on chain. There are projects working on this, for example, within the account abstraction-ish space. For example, like the Universal Profiles crew has built out a really cool on-chain key share manager that allows you to attach keys on chain. I'm sorry, controller keys and delegate. So that's really cool stuff. I highly recommend looking at that. And Ethereum really can't have any way to like enforce wallet level constraints like these policies. So, and there's still kind of like something to be explored there with MPC-based co-signing on chain. But I have some good news, guys. I really do. Today, if you want to be building with safe, scalable agents on chain, there is a framework for this. It's called Wallet as a Protocol, and it was built with the design philosophy of embedding autonomy with human agency as a design primitive, right? So WAP does have all of these features that I've talked about today, where we have human-bound key generation. We use 2PC MPC to split the key share so that any AI or agent or any automated process can be used to drastically reduce the attack surface for a wallet being compromised or a key being compromised, and I can talk more about that if folks are interested. We can do things like scope delegation where the user can set permissions for how they want to be able to transact or what they consider high or low security conditions. And for dapps, it's stateless. They don't need to think about security, the agent. They don't need to think about UX. They just embed a few lines of code, and they're able to onboard users without worrying about all of this stuff. So WAP plus Ethereum is really what's going to make AI agents prosper and really flourish on Ethereum. This is where we're going to have humans defining and holding the keys, right? These controller keys. Agents become these copilots. We're going to be leveraging MPC until we can move more of this on chain for scaling safe automation. And this is really how we get Ethereum to become the backbone of a human aligned AI infrastructure. So this is my call to action to you guys. I always have to end on one of these. It's live. You guys can build with it right now. If you want to go over to the co-working session, I'll walk over with you and we can check it out together. Go to wap.build. You'll have a portal where you can get started in a few lines of code and put together basically an embeddable experience for your users. And that has some already like built-in agents for transaction simulation and risk monitoring. So yeah, I mean, that's all I got for today, guys. Like, yeah, I don't have any more slides. Does anyone have any questions? Would you guys like to see it in action, perhaps? Yeah? All right. Okay, so hopefully the internet's cooperative here. Here's a web app that we built for our community, for our DAO. So here what I'm doing is I'm logging in, and, oh, whoops. All right, here's a web app that that we built for our community. It's for our DAO. And yeah, so let's just go, it's not really important what it does, but let's just go through the user experience here. So I'm going to log in. So to log in, I'm actually creating a human-bound key. And I'm going to be really quickly get my email. I'm getting an authentication request through a magic link, which you guys are very familiar with if you've logged into the DevCon app with Para. It's very similar. Da-da-da-da. If I'm lucky, I'll get an email. Oh, wait. Let's see. Which mailbox am I in? Oh, is this it? I just had my mail app update and I have no idea how to use it. Let's see here. Go to next mailbox. Next mailbox. There we go. Shoot. All right, guys. Well, I can't access my email at this moment. Not cooperating with me today. But if you guys want to see a demo, I'll be around. But happy to take any questions in the meanwhile. Yes, please.
Does it work? Can you hear me?
You're very echoey.
Now?
I can kind of hear you.
Yeah. Can you elaborate on the MPC aspect of your framework? How do you use
So the question is, how do we use MPC? We use MPC in two ways. The first way is we have something called the human network, which allows us to create human-bound keys. Human-bound keys are derived from human attributes, and they compute something called the OPRF. So the OPRF is, I believe, a pseudo-random function, and we are able to compute this in a threshold network so that we can take some biometrics and create a key from it safely. The second way that we do this is for signing. So that second key that I talked to you guys about, where we split the key and give it to a user, that key is actually stored in a network called ICA. ICA is an incredible project that was started by a bunch of cryptographers that were tackling the two-party ECDSA challenge. And so once you solve this, you can have really scalable MPC with hundreds or maybe even thousands of nodes. So what we do is we put that signing key within ICA and then predefine within a smart contract some policies that we care about. Like, for example, spend limits that the user sets, or say like risk levels that we don't tolerate or that require additional authentication. So the ICA network executes consensus on these policies as well as the inputs that are coming in. So for example, oracles for say like the risk level. And then that's fed back to the user, and then the user is able to see what's happening in a human readable output before signing a transaction. Is that a question? Is that a question or no?
All right.
Well, if there's no more questions, thank you guys.